Halo, Assalamualaikum warahmatullahi wabarakatuh. This is me, Mrs. Marina Tiara. I want to make a presentation in introduction to Signal and System. First, I want to make this content compact, yeah. So I want to tell you about what is all about in Signal and System. So definition of signal. Signal as representation of physical quantities, classification of signal, continuous time as discrete time. Yeah. Now definition of signal. Signal is a mathematical function representing the variation of a physical quantity with respect to an independent variable, usually time. Yeah. Signal convey information about a system or a process. So it consists of signal, yeah, information, and then mathematical representation. A signal is essentially a mathematical function denoted as xt in continuous time or xn in discrete time. Yeah. X represents the signal and t or n is independent variable. Time in continuous signal, discrete instances in discrete signal. Dependence of an independent variable. The value of the signal varies concerning the independent variable, often denoted as time. For example, in continuous time signal, xt signifies how the signal changes continuously by time. Role in signal in system representation. Information conveyance. Signals serve as carrier for information about a system or process. Variation on the signal provide insight into the behavior, characteristic, or state of the system. And then characterizing physical phenomena. Yeah, signal, yeah, enable the representation of physical phenomena such as electric voltage, temperature, pressure, or biological data, like in EEG. Yeah. The mathematical representation allows for the analyzing and understanding of these physical quantities. And then system interaction. Signal are the means through which systems interact with and respond to their environment. They are fundamental to studying how systems process and transmit information. Now this is continuous signal, this is discrete signal, yeah. And then example of signal representation. This is the continuous signal example. Consider xt is the same as seen inside it. 2pt plus theta representing a sinusoidal signal. Here A is the amplitude, this amplitude, F is the frequency, T is time, and theta is the phase. Yeah. And then discrete time signal example. Xn equal as An, representing a discrete time exponential signal. Here, A is a constant and N represents discrete time instance. Note, the mathematical representation of signal is a fundamental concept in signal processing and system analysis, forming the basis for understanding and manipulating signal in various engineer applications. And then physical quantities. Examples of physical quantities include voltage, current, temperature, pressure, and sound. Signal provide a way to analyze and understand these quantities. Yeah, so you can find it in if you make practice or final project or whatever. Yeah, and then physical quantities and signal. Example of physical quantities, yeah. So you must understand it because it relates to signal. Voltage represents the electric potential difference between 2 points in electrical circuit. It is a key parameter in electronic and power system. Current is the flow of electric charge in a circuit. It is a fundamental quantity in electronics and plays a crucial role in circuit analysis. And then temperature is a measure of the average kinetic energy of particles in a substance. Signal representing temperature variation are vital in fields like climate monitoring and industrial process. And then pressure is the force applied perpendicular to the surface of an object per unit area. Pressure signals are essential in areas such as fluid dynamics and industrial process. And then sound signal represent variations in air pressure that our ears perceive as sound. In acoustic and audio engineering, signal convey information about sound wave. And then signal as analytical tools. Yeah. Representation of physical phenomena. Signal provide a means to represent and analyze these physical quantities mathematically. This representation allows engineers and scientists to study and understand the behavior of these quantities. Transformation and analysis. Signal enables the transformation of real-world phenomena into mathematical form that is amenable to an analysis. Techniques such as Fourier analysis allow for the decomposition of complex signal into simpler components. That's why we need Fourier. And then system response. Analyzing signal help on understanding how systems respond to different input, providing insight into the system of characteristic. And then diagnostic tool. Signal are used as diagnostic tools in various fields. For example, an oscillating voltage signal could indicate a fault in an electronic circuit. And then importance of signal analysis, efficient communication. Understanding signals is crucial in designing efficient communication systems where information is encoded and transmitted as signal. Control system. In control system, signals are used to represent desired and actual system behavior, enabling feedback and control. In biomedical application, yeah, in biomedical engineering, signals such as electrocardiogram (ECG) represent physiological parameters, aiding in medical diagnosis. Note: signals serve as a bridge between physical world and mathematical model, allowing for the analysis and manipulation of various physical quantities in engineering and scientific applications. Signal are characteristic. Yeah. There is three: amplitude, the magnitude or strength of the signal; time dependence, how the signal varies with time; and then frequency, the rate of oscillation for periodic signal. Now you can read this, yeah, because it's still a lot. And then time dependence, yeah, time dependence and type of time dependence, yeah, and then frequency, yeah. I hope I can. Interrelationship, amplitude and signal modulation, yeah, and then application, audio signal, and then communication system like AM, FM, common integer communication, yeah, and then audio signal amplitude represent loudness, frequency represent pitch. Understanding this characteristic is crucial in audio engineering. Yeah. Analyzing and understanding signal characteristics are essential in signal processing. Yeah. Communication system and various engineering applications, allowing for precise manipulation and interpretation of information encoded in signal. And then importance of signal representation, analysis and understanding. Signals enable the analysis of system and process by representing signal phenomenon in manageable form. Yeah,